Hey folks, how's it going? This is Mr. Moray coming to you with a recap on the surprise activity, which is essentially the Vertex Form with Analysis handout. Alright, so in this video I'm going to walk us through how do we construct the graph of this function, f of x equals negative, in parentheses, x plus 5 squared plus 4, which is in vertex form, and I'll also take you through the analysis as well. All right, so this you got to actually read the graph a little bit carefully. So here is 0, 0. I'll label the origin. 1, 2, 3, 4, negative 5, 1, 2. So negative 5, 4 is the vertex of this function. I'm going to label that in a different color so we don't get that confused with the origin. Okay, so I'll do this in blue. Now we know negative 5, 4. One way to know is that it's whatever the opposite of this number is. So 5 makes it negative 5. Or, in other words, whatever makes the parentheses equal to 0. Because this is negative. So what you're doing is you're taking a number away from 4. So, for example, if I plug in 1, 1 plus 5 is 6. 6 squared is 36. This makes it negative. So essentially you're taking away 36 from 4. And so the least you can take away from a number is 0, right? You literally take away nothing. So if I make x negative 5 plus 5 is 0. So that's going to represent the maximum because that represents having taken the least amount away from positive 4. All right, so down here, I'll go ahead and because I've got a nice, I'll split this here. So because I've got a nice graph here, I can go ahead and split that up. All right, so what I have is my vertex of negative 5, comma 4. Okay, and now I've got my x and my y. So negative 5, 4. And you can go ahead and make some other points. I'll plug in negative 4 and negative 6 because those have to have the same y because they're the same distance away on the x-axis from negative 5. So if I plug in negative 6 plus 5 is negative 1. Negative 1 squared is 1. This makes it a negative 1. You add 4 and you get 3. Okay, and you should see the same thing on the other side. All right, now what I would do is I would plug in negative 3, which has to be the same as negative 7 because those are each 2 away from negative 5. Negative 3 plus 5 is 2. 2 squared is 4. This makes it a negative 4. And I add 4 to get 0. Okay? And then using what I know about quadratics, I know that I can just generate one more point just to make my graph a little bit nicer. Okay? And now that I have this, let's go ahead and try to analyze here. Okay, this should be your graph. So my domain, well, the domain we know is negative infinity to infinity. That's true of all quadratics. The range, we can see it's pointing down. So it goes from negative infinity on the y-axis all the way up to 4. And we can see that 4 from the vertex. Right, the vertex is negative 5, 4. Okay, where is it increasing? So if I trace my finger from left to right, it's increasing from when x is negative infinity, way out there, all the way to when x is negative 5. And then it's decreasing starting at negative 5 and going on to infinity. Now the big mistake people make is they say, actually, this should be negative infinity, right? Actually, no, because I'm talking about the x's and not the y's. All right, now quickly I'm going to identify my x-intercepts. So one is negative 3, 0, and the other is negative 7, 0. Okay, and that means if we can see here, where am I positive and negative? So I'll trace the positive with green. Okay, so I'm positive from when x is negative 7 to when x is negative 3. I'll just clean that up a little bit. So starts when x is negative 7 and ends when x is negative 3. And then it's negative in 2 places. It's negative once here, and it's again negative here. So I'm going to have 2 intervals. One that goes from negative infinity to negative 7, because remember, these are x's. So from when x is negative infinity to when x is negative 7, we're negative. And also from when x is negative 3 to onward to infinity. So remember, the domain increasing, decreasing, positive, and negative are all x values, and only the range is going to be y values. And lastly, the y-intercept, that is the coordinates. And to know that, you have to plug it in. So you'd plug in 0 for x. Okay, so you'd get 0 plus 5. That's 5. 5 squared is 25. This makes it a negative 25. And adding 4 gives you negative 21. All right. So that's the analysis. So please make sure you understood how I got each of these items, and make sure you got the same thing on your surprise sheet. If not, this would be a time to think of any questions you might have and try to think about where I got this from. Remember, one of the big mistakes people make is that they get confused with the x's and the y's, especially with increasing and decreasing. But remember, it is the x's that determine the y's. So that's why so much of this is based on x's. Because when I know an x, I can get a y. Okay, so that's important. So what about transformations from the parent function? So that's a good question. So here I've got my 1 and my 1. Okay, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to go ahead and really quick, I'm going to graph the parent function here. And I want to ask myself, what do I need to do to transform this function onto this function? There's not exactly one right answer, but let's take a look and see if we can figure it out. So first of all, I'm going to give you one example answer. So first of all, I noticed that this is pointing up while this is pointing down. So I'm going to start by with a reflection over the x-axis, or you could also say y is equal to 0, because those are the same line. All right, and so what that will do, if I do it like that, is it will take this graph, and I'm going to do it in purple. It will transform the graph into this graph, 1, 2, 3, 4. You can imagine transforming it over the x-axis, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. You can imagine I'm doing this dotted graph right now. This is the reflection. And now I need to get this reflection on top of there. So that means what I need to do now is I need to translate left by 5 and up by 4. And when I do that, the purple will go 1, 2, 3, 4, 5. So what I say is stick to the vertex. Start with the vertex, because these are what we call rigid transformations or rigid motions. And what that means is that when I move a point, for example, a translation, when I move one point left by 5, every other point moves left by 5. When I move it up by 4, every other point moves up by 4. When I reflect over the x-axis, every point reflects the exact same amount. And that's how it keeps the same size and shape. So what I'm going to only worry about is getting this vertex to this vertex, because once I can do that, I know, because this is a rigid motion, that everything else will follow suit. Okay, so these are the two transformations, a reflection and then over the x-axis, and then a translation left by 5 and up by 4. This is not the only way to do it, but note that in this case, it actually does matter the order. If you move it over by 5 and up by 4 first, then you're not going to reflect over the x-axis. You're instead going to reflect over this line, y is equal to 4. Because if I'm up here and I reflect over the x-axis, now all of a sudden everything's going to be way down here. So it's just something to think about. All right, so hopefully this video made sense to you. Please make sure that all of your answers are correct. And if you have any questions, please reach out to me to let me know. For now, we're going to continue to build up our skills. If you don't know the transformations, it's not the end of the world, but the analysis stuff is extremely, extremely important, okay? So keep it up. All right, keep the questions coming. Don't forget to love math. And remember, you can do it. All right, thanks for watching. Have a wonderful day, and I'll see you next time.